Good morning, all of you. Let us study today photochemistry. What is photochemistry? What are the different laws of photochemistry? Then, differences between photochemical and thermal reactions. What are the differences between photochemical and thermal reactions? Next, we'll study quantum yield. What is called quantum yield? What are the reasons for high, low quantum yields? That is due to primary and secondary process in photochemical reactions. We will study in detail. So, what is photochemistry? Photochemistry is a branch of chemistry which deals with the study of chemical reactions induced by or initiated by light. Those reactions occurs in the presence of light are called photochemical reactions. It is the branch of chemistry which deals with the study of photochemical reactions or chemical reactions induced by light. For example, photosynthesis of glucose. Photosynthesis of glucose from carbon dioxide and water in the presence of sunlight and chlorophyll. Chlorophyll is a photosensitizer. Energy poor molecules, carbon dioxide and water or energy poor molecules are converted into energy rich molecules. Therefore, delta G is positive. Whereas on combustion of glucose, energy is released, delta G will be negative. So, what is photochemistry? In other words, it is the study of reactions, chemical reactions or biochemical reactions that are brought about by the action of light, especially mostly UV visible light. So, what is light energy? The reactions occur in the presence of light are called photochemical reactions. Therefore, what is light? What is light energy? This is the light source. The light radiations are emitted in all the directions. The light radiations are electromagnetic radiations emitted in discrete packet. They are emitted in discrete packets. You see, discrete packets called quanta. Each packet is called photon. Now, what is photon? It is the smallest amount of, this is one photon. Okay, the smallest amount of light carrying the energy. What is the energy of each photon? Energy of each photon is given by Max Planck equation. E is equal to h nu equal to h by c by lambda. Nu equal to c by lambda, we know. H is called Planck's constant. C is the velocity of light in vacuum. Lambda the wavelength of light, electromagnetic light. Nu is the frequency of the light wave. In other words, what is called photophysics? What is photochemistry? The study of interaction of electromagnetic radiation with the sample or matter resulting in a physical change. If physical change only occurs by the interaction of electromagnetic radiation with matter, or the study of interaction of electromagnetic radiation with the a chemical molecule resulting into a chemical reaction is called photochemistry. In general, during chemical reactions, bonds are broken and formed. Bonds are, for example, nitrogen plus hydrogen gives ammonia. Nitrogen bonds are broken, hydrogen bonds are broken, NH bonds are formed. So the chemical bond energies are in the order of the bond energy required to break a chemical bond, single bond or double bond or triple bond, 100 to 1000 kilojoule per mole. So what are the radiations of appropriate energy to break this bond? UV visible light energies. UV visible light energies, you see, infrared 151 kilojoule per mole only. It is not sufficient enough to break the bond, whereas UV light, the energies of UV visible light are sufficient enough to appropriate enough to break the chemical bond. So UV visible light energies are in the range of bond energies. During the absorption of UV visible light, electronic transitions takes place. We'll study more. So photochemical reactions mostly take place in UV visible region, which is expected to induce chemical reactions. Now, what are the differences between? We have already studied thermal reactions. What are the differences between photochemical reactions and thermal reactions? It is very simple. It involves absorption of light radiations. For example, photosynthesis. It involves absorption of light radiations. Here it involves absorption of heat. Here light energy. Here it involves absorption of heat energy or evolution of heat energy. For example, thermal decomposition of calcium carbonate to give CaOCO2. This is endothermic reaction, whereas ammonia formation during Haber process is exothermic process. So thermal reactions involves absorption or evolution of heat energy. Photochemical reactions occur in the presence of light, that is light radiation. Light is nothing but an electromagnetic radiation. It depends on wavelength and intensity of the light. These reactions can take place in light as well as in dark. Temperature has very small effect on photochemical reaction, whereas in thermal reaction temperature has significant effects because it involves absorption of heat or evolution of heat. In photochemical reaction, the change in free energy may be positive or negative, but in thermal reaction the change in free energy is always negative because delta G equal to delta H minus T delta S. See, exothermic or endothermic, this is different. Delta G, exergonic, endergonic, this is exergonic, this is exergonic, this is endergonic. Okay, so for example, delta H may be negative, but delta H, for example, endothermic reaction, delta H is positive, but temperature at high temperature only it takes place. Therefore, the overall delta G will be negative. So you please understand why delta G is always negative because of this. Next, photochemical activation is highly selective process. For example, chlorophyll. In the presence of chlorophyll, only the photosynthesis takes place. So photochemical activation is highly selective process, whereas thermal activation is not selective. Several reactions are initiated by photosensorizers or not necessary. Some reactions occurs without photosensorizers. These reactions are accelerated by catalyst. Then the rate of reaction is enhanced in the presence of catalyst. Here the reactions are initiated by photosensitized in some cases, not all cases. The photochemical reactions, another important point is that photochemical reactions have generally zero order reactions. They have zero order because no activation energy is involved. Collision theory is not applicable for this. Whereas they have non-zero order reactions, they have zero order or non-zero order because activation energy is involved using collision theory. Here we will see the laws of photochemistry like laws of electrochemistry. There are two important laws of photochemistry. They are Grotthuss-Draper Law, Stark-Einstein's Law. Let us first see the first law of photochemistry. It is also called Grotthuss-Draper Law. According to this law, only the light photons, only the light energy which is observed by a molecule can undergo photochemical reaction, can be effective in producing photochemical changes in the molecule. Those molecules which have absorbed the light photons only undergo chemical reactions, that is photochemical reactions. That is, in other words, light must be absorbed by a chemical substance in order to undergo a photochemical reaction. In order to initiate a photochemical reaction, light must be absorbed by a molecule for photochemical reactions. According to this law, all the light radiations are not bringing the chemical reactions. See, only those light energy absorbed are effective in causing photochemical changes. All light radiations are not bringing the chemical reactions. For example, some photons will collide with the molecule, will increase the kinetic energy of the molecule, while some are re-emitted after immediate absorption. That is called fluorescence. The light is absorbed by the molecule and immediately emitted fluorescent. They are called fluorescent substances. They absorb light and immediately emit the absorbed light. That is called fluorescence. We will study further in Jablonski diagram. Let us now study the second law of photochemistry. It is also called Stark-Einstein's Law, also called Law of Photochemical Equivalence. It states that for each photon of light observed by a chemical system, for each photon of light observed by a molecule in a chemical system, one molecule is activated for a photochemical reaction. This is represented as here, that is the energy of the photon equal to Eh nu. This is the source. The source is emitting the photons, the light radiations. I naught is the intensity of the incident beam. It is the intensity of the transmitted beam after absorption and other process. So I0 minus IT equal to IA. IA is the intensity of the light absorbed. In other words, the Stark-Einstein's law is stated that one quantum of radiation observed by a molecule activates one molecule in the primary step of photochemical process. This step is called primary step. This is the primary step. After the primary step, we will see secondary step. Now, the energy observed by in chemistry, we measure substances in terms of moles. So, the energy observed by 1 mole of reacting molecules is given by E is equal to N into H nu. Capital N, where N equal to Avogadro's number. This energy is called 1 Einstein. 1 Einstein is called the energy of 1 mole of photon. Energy of 1 mole of photon. Okay. Let us see what happens when light photon is observed by a molecule. Let us consider ethylene molecule with pi bond. There are 2 electrons, pi bonding, anti-bonding orbital, pi star. So there are 2 electrons placed according to Pauli exclusion principle. So in the ground state, the spin multiplicity is calculated as follows: S equal to 1 by 2 upward spin, downward spin plus of, so downward spin minus of equal to 0. The spin multiplicity is 2s plus 1, therefore 2 into 0 plus 1, 1 singlet state. The ground state is singlet state, is 0. And when a photon of light falls on the ethylene molecule, it observes the light photon. One of the electron is promoted to the higher pi star level. Okay. Now this is again singlet state because plus of, this is minus of. This rearranges, this undergoes secondary process to give triplet state. The spin rearranges. Okay. So triplet state, S equal to 1 by 2 plus 1 by 2 equal to 1. This is a triplet state, 2s plus 1, 2 into 1 plus 1, triplet state. A triplet, this is more stable. Why this is formed? Why this is produced? This state is more stable than the singlet state. Because in triplet state, the unpaired electrons, these are unpaired electrons, less interaction, less repulsion take place. Whereas in singlet state, the electrons are paired. So more interelectronic repulsion than this. Therefore, this is slightly unstable than this. So the energy of triplet state is lower than S1. We will further study in Jablonski diagram. We will study further. Often problems were asked in IIT JAM and in GATE, CSIR and in many competitive exams. What is the value of 1 Einstein? What is the energy of 1 mole of photon? That is Einstein is given by, so N equal to hc by lambda, where N equal to Avogadro's number per mole. C is the velocity of light, h Planck's constant. By substituting these values in this expression, we can obtain in CGS unit. These are used for problems, solving problems. So if lambda is given in centimeter, what is the energy of 1 mole of photon of radiation of wavelength, for example 1 centimeter or 0.0010 power minus 7 centimeter. Once you know the wavelength of the electromagnetic radiation, we can calculate the energy of 1 Einstein, that is 1 mole of photon in SI unit. Lambda, if lambda is given in the wavelength of electromagnetic light radiation is given in meter, then in joules you use this formula. Okay. Another important term used in photochemistry is called quantum yield or quantum efficiency. What is called quantum efficiency or phi? That is number of molecules reacting divided by number of photons of light observed in the same time. For example, 1 photon light observed, 1 molecule reacted, then phi equal to 1. Suppose 1 photon of light observed, 100 molecules reacted, then phi equal to 100. Therefore, it is defined as the ratio of number of molecules reacting in a given time to the number of photons of light observed in the same time. Experimentally, how the quantum efficiency is determined? It is obtained from the rate of the chemical reaction and then how much light energy is observed per second. So, the rate of reaction by means of kinetic measurements, we can determine the rate of chemical reaction. By actinometer, we can find out, we can photometer how much light energy is, how much Einstein, how many photons are observed per second. Based on quantum yield, there are 3 types of photochemical reactions. Based on quantum yield, if phi equal to 1, the product is produced in primary photochemical process. There is no secondary process. Okay. For example, phi equal to 1, hydrogen sulfide is irradiated with the electromagnetic light radiation with the wavelength 208 nanometer. It is excited in the primary step, and because of the bond is weakened due to electronic transitions, H2, the bond is broken, H2 plus S. In this case, phi equal to 1. Why phi greater than 1? When chain reactions occur, for example, photochemical reaction between hydrogen and chlorine, chain reaction occurs, and also exothermic. This step is exothermic. So, we will study further what are the reasons for high quantum yield, what are the reasons for low quantum yield. We will explain very clearly. And in the photolysis of bromine and hydrogen, the similar mechanism here endothermic, therefore physical deactivation of excited molecule is dominant, is majorly taking place. Therefore, phi is less than 1, 0.01. Now we will see what are the reasons for high quantum yield, low quantum yield. One photon is observed, 1 molecule react, then phi equal to 1. Now what are the reasons for high and low quantum yield? There are 2 processes taking place during photochemical reactions. One is primary process. If only primary process takes place, then phi equal to 1. See, phi equal to 1. If secondary process takes place, for example, chain reaction, exothermic process, endothermic process, then the quantum yield for the photochemical reactions are either high or low. We will see what is now primary process. In primary process, the molecule observes a photon of light. To become excited, the excited molecule give directly product. The excited molecule is formed in the primary process. It is directly converted to product. Or in the case of chlorine, it absorbs a light photon and gets dissociated to give atoms. The excited molecule may get dissociated to give atoms or free radicals. Okay. Now, what are called secondary process? Why do we study secondary process? Due to these secondary process, the photochemical reactions will have high quantum yield or low quantum yield. Now we will see what are secondary process and also reasons for high quantum yield. Because of secondary process, the species formed in primary process reacts further to give rise to high phi. The product is the reactant, the excited molecule is not converted to product, but instead it reacts further with other molecules to give rise to phi. Sometimes in the secondary process, the free radicals initiate chain reactions. The free radicals, for example Cl2, initiate chain reactions in the photolysis of chlorine and hydrogen. These Cl dot is produced. The highly reactive atoms initiate chain reactions and leading to high quantum yield, phi greater than 1 million, that is 1 million. If the secondary process, for example, this is primary process. In the secondary process, the secondary reactions are exothermic, the heat released activate further the reactant molecules, resulting in high phi value. Okay. Now, what are the reasons for low quantum yield? The reasons for low quantum yield are also due to secondary process. The A star, the excited molecules, gets deactivated to give back the reactant. See, the photon is lost. The energy of photon is lost now. Therefore, the quantum yield is low. A star collides with the excited molecule collides with the normal molecule to form 2A. These collisions between the molecules deactivate the excited molecules. Another reason for low quantum yield is that dissociated atoms or radicals combine to form reactant molecule, reactant bag. Okay. If the secondary reactions, in the case of photolysis of bromine and hydrogen, phi is very, very low because the bromine radicals, the bromine atom, highly unstable reactive atoms, reacts with the hydrogen to give HBr plus H. This reaction is endothermic, whereas in the case of H2 plus Cl, this is exothermic, the heat is released. Therefore, if the secondary reactions are endothermic, the heat absorbed inactivate the excited molecule, resulting in low quantum yield. What are the factors influencing quantum yield? What are the factors affecting quantum yield? Effect of temperature, effect of wavelength, effect of intensity, effect of addition of gas, etc. What is the effect of temperature? Increase in temperature increases quantum yield because all primary photochemical process is endothermic. Therefore, quantum yield increases with the increase in temperature. Effect of wavelength. What is the effect of wavelength? As we lower the wavelength, the energy increases. The energy of photon absorbed is very large. Therefore, the quantum yield will be higher at the lower wavelength. Okay, and vice versa, the quantum yield will be lower at the higher wavelength, or the quantum yield will be higher at the higher frequency. Another factor is intensity of light. It increases, the quantum yield increases with the intensity of light. For example, laser beam consists of lot of photons, concentrated photons of monochromatic wavelength. If one molecule absorbs one photon, then it is called a monophotonic process. If one molecule absorbs two photons, see, because of laser high intense beam, one molecule absorbs two photons, then it is called biphotonic process. If one molecule absorbs many photons, then it is called multiphotonic process. What is the effect of addition of inert gas? The addition of inert gas in photochemical reaction always decreases the quantum yield because of collision. Because of collision with the excited molecule, it deactivates the excited molecule to give back the reactant. Thank you for watching.